All right, guys. So today we're going to look at something that we actually didn't do last year, but I talked about it last year, and I said that you were going to do it this year, is infinite limits, okay? So you're going to learn what those are, how to figure out what those are, but first, I just kind of wanted to point out, all right, do limits always exist? Of course they don't. If you have something like this where it doesn't exist from both sides equally, then that would be a DNE. And then we just talked about that oscillating one as well. Okay? So as you're looking at this, if I asked you what is the limit at 1 for this graph, you would be able to do that. If I asked you what's the limit at -1, you would be able to do that. If I asked you what is the limit as x is approaching 0, very, very hard to see what's going on there. Okay? So in both of those cases, obviously your answer would be D and E. So what about asymptotes? So for an asymptote, it pretty much means when you are plugging in whatever you're finding the limit of, it's going to give you a 0 in the denominator. So that kind of goes with that whole domain situation that you guys learned last year. Okay, so here's what we're looking at. Here's our graph. As you're approaching 0, let's see, on this one, I guess that doesn't really go together. Let's change this to, instead of 0, let's change this to an A so I can kind of explain it a little bit better. Okay, so as you're looking at the asymptote here, notice that as you're coming in from the left, you are going to negative infinity. As you're coming in from the right, you are also going to negative infinity. So since they are both trending towards negative infinity, then that would be a limit of negative infinity. Now, when would an asymptote not give you a limit? Anybody have an idea? So here's our asymptote, and actually let me make it a dotted line. There we go. So we have an asymptote. Yeah, if they're going in opposite ways. Is that what you're going to say, Clark? Yeah, absolutely. So say this one you're coming in from this direction. This one you're coming in from this direction. Obviously, you're going to positive infinity. From the right, you're going to negative infinity. So for that case, it would not exist. All right. Pretty simple to spot, really. So looking at example 1, we're going to answer these questions based on this graph off to the right here. So as x approaches 0, what is the limit? So that means we are looking from both directions. What do you got? It's actually a little bit below that. Yeah, so 0.6. There we go. All right. -1, so at -1, again, we are looking at both sides or both directions. What's your answer? And you can put a plus infinity, but I am okay with just infinity. I think Mrs. Rung liked to use a plus infinity, but I figure as long as you don't put a negative, we know that it's plus. All right. Approaching 2 from the left. So positive 2 from the left. What is it? Negative 0.6. I would say 0.5 on this one. Yeah, I would say 0.5. It's pretty close to that, yeah. All right, as we are approaching 2 from the right, thank you. You too. 2 from the right, what is it? Negative 0.5. So the next question that I want to ask, because it's not on here, let's go ahead and do as x is just approaching 2 from both directions. Does it exist? Yeah. Going to the same value, right? So same exact value. So the limit as we are approaching 2 from both directions is also, I'm going to put that f of x as well, also negative 0.5. I just realized I put a 0 in there. Yep. All right. F of 2, what is it? Why is it -1?
Because it's filled in.
Okay, that's where it's filled in. Perfect. Limit as x approaches +3. I mean, it exists. Is there enough? Yeah, you can't see it over there. So here's what we're going to do. Let's switch it to a -3 instead. All right, limit as we are approaching -3. What is it? D and E. Why? Why is it D and E? Approaching from different sides. Does the function exist there?
Yes.
Yes. What is the function value?
Like 0.7.
Is it 0.7? Yep. We're going to go with it. We're going to go with it. Okay. All right. Are you guys okay there?
Yes.
Awesome. Awesome. Okay. All right. So here is what you need to look for when you are given just an equation. Okay. Can we do direct substitution? I did teach you direct substitution last year, so hopefully it comes back to you a little bit. Okay? Now, obviously, direct substitution isn't always going to work. Does it work here?
Yes.
Yeah.
Yes.
Yeah, because, I mean, everything's going to work out, right? So 2, you've got a 2 on top. And then on bottom, plug in 2. You do get 2/5. And if you were thinking about what that would look like on a graph, obviously the 2 would be your x coordinate, the 2/5 would be your y coordinate, and the limit does exist there. Okay, so that is kind of combining both of those concepts. Now, can I plug 1 into here?
No.
No. Now, we did look at one like this yesterday, if you guys remember, and I showed you the graph. Do you guys remember what the answer was yesterday? No, it existed. The function doesn't exist there, but do you guys remember? If you don't, it's fine. It's no big deal, because I'm going to show you how to do it algebraically. Okay? What do you notice about this problem? There you go. So if you can change it in some way to make it work, then do so. Obviously, you can't just plug in 1 as it is. So the x minus 1s are going to cancel, and that leaves you with 1 over x plus 1. Can we plug 1 into that one?
Yes.
We can. So 1 over 2. And then if you did bring up that graph from yesterday, you would notice that it did have a limit at 1/2. You just had an open circle there, because the function didn't exist there. Okay? Make sense?
Yep.
Yeah.
And pretty much any time you have a rational function and you can cancel a factor on top and bottom, we talked about this briefly last year. If you can cancel a factor, it gives you that whole, which is how you know that you're going to have an open circle there.
So you said the function does not exist, but the limit does.
Function does not exist, limit does. Yep. So remember, I think it looked something like this. And then you just had a hole right there. Okay, and that hole was just you canceling those two factors. All right, last 3, guys. Now these 3 are a little tougher. So notice my voice is slowing down. I'm going to try not to talk so fast on these 3, because I do talk really fast. Looking at this one, we are approaching only from the right. Okay? One-sided limit, only approaching from the right. However, can I plug in 3? No. Obviously, that's going to give us 3 over 0. So the next step would be, all right, well, like on that previous one, can we simplify this in some way? We can't, right? There's nothing we can factor. There's nothing we can cancel. So how can we go about this instead? So you guys are going to need to do a little bit of logic on these kind of problems, okay? If you can't simplify, let's figure out another way, okay? If you are approaching from the right, your numbers are obviously going to be bigger than 3, correct?
Yeah.
So try a couple. All right. Let's look at 4. Okay. So 4 over 1. Now you need to get closer and closer and closer to 3. Okay. Let's try 3.01 or 0001. Okay. If I put 3.001 into there, we'll just do 3 zeros to start. And then I put 30001 there, and I subtract out 3, what do I have left over? Okay. Divide that.
You're approaching.
We are approaching infinity. So this is really super close, right? Really super close to 3. As we would try to get further away, you're going to see that those numbers are going to get smaller. So as we're getting closer, we're getting bigger and bigger and bigger and bigger and bigger. Okay? So for this kind of problem, just plug some stuff in, see what happens. Okay? The top is going to remain positive always, right? Because if we're bigger than 3, aren't we always going to be positive when we plug that into x? Okay? If we're bigger than 3 and we subtract out 3, aren't we still going to be positive? Okay? So if you have a positive over a positive, which basically you're looking at positive infinity over positive infinity, your final answer is positive infinity.
I understood everything up until that.
Up until that very last step. What about the plus over the plus? Are you okay there? Okay, so when we tried this, all right, when we were just kind of talking through it, we saw that as we got closer and closer and closer, and this is pretty darn close to actual 3, okay? As we were getting closer and closer and closer, we were just continuing to rise, okay? So that's one part of it. So we could have just finished this problem, Haley, just looking at it in this direction. But this whole plus over plus, we need that for these two, so I went ahead and introduced that as well. So, you said you needed me to explain the plus over plus, right?
I understood the plus. So you're just saying, like, as you get closer
Yeah.
to 3 and, like, those
So-
zeros keep going?
Yeah,
that's when it gets
so
bigger.
pretty much, since I knew it was going to be infinity because of the way this is set up, anytime you have a 3 over 0 or any number over 0, it's going to be trending towards some kind of infinity. Okay, so what I did then was I said, all right, no matter what number I plug into x that is above 3, it's always going to spit out a positive number. Okay, no matter what number, as long as it's above 3, no matter what number I plug into the bottom x, if I subtract out 3, it's still going to be positive. Okay, so that's how I knew plus over plus, and then that's how I knew that it was going to be. So it was just 2 separate ways to do the same problem. Okay?
If it was a 3 approaching from the left, would it be the same answer?
Let's see. So 3 approaching from the left, you would just do it in the same way.
And it would end up being
Yeah.
32.
Yeah. Hi, Sebastian.
No.
All right. Next one, guys. Welcome back to Trig.
No.
Momentarily. It's only one example, so I'm like easing you back in here, okay? Sebastian, they all hated trigonometry last year. So, all right. Secant. Let's not remember what the graph of secant is. We can actually do this by remembering what the graph of what is. Cosine. That's a lot easier to remember, right? So we can actually change this secant to 1 over cosine x, and it's still going to work for us because we're going to do it similarly to how we did that last one with that positive over negative or positive over positive or whatever. Okay? There are several different ways you can go about this kind of problem. Okay? I want to kind of remind you of a few things, so we're going to talk about a couple of them. Do you guys remember this? What was this ordered pair?
1, 0.
And cosine sine, correct? I know. All right, what was the angle measure here?
0.
It was 0. So we're going to go 0 degrees or 0 radians. What is this point here?
0, 1.
And then, yes, pi over 2.
Also known as 90.
And again, CS, also known as 90. Perfect. We're going to go ahead and continue all the way around just because it's going to be good for you guys to see this again. What is this ordered pair?
-1, 0.
Perfect. And CS. And then what is that in radians?
5, 180.
Pi, which is 180. Last one, actually second to last one, so I'm going to go ahead and put this last one on here as well. What is this one? 0, -1, which is 3 pi over 2. What was that in degrees? 270. And if we swing all the way back around, this is also 2 pi. So 0 radians or 2 pi radians. The next thing is the thing that's going to actually help us, okay? Do you guys remember how to tell what the signs are in each quadrant?
All students.
There you go. All students take calculus.
That's us.
All of you guys.
That's
See,
us.
there was a reason why we did it, right? Okay, so like I said, this is actually going to help us here. Okay? As we're going, as x is approaching pi over 2, which is 90 degrees, which you guys said is up here, we're coming from the negative direction. Okay? So that actually means that we're looking a little bit below pi over 2. So if pi over 2 is 90, what is a degree that is a little bit below that?
89.
Where is 89? What quadrant?
First.
It's in the first, right?
That's
Yeah,
fine.
it's in the first quadrant. So as we're approaching pi over 2, cosine is... Nope, we're approaching... Well, it's approaching 0, but that's not what we're looking for. Because technically, if we plugged in pi over 2 to cosine, we would end up with 1 over 0. So we know it's going to be infinite. You see what I'm saying? Okay, Brett.
So wait, how would it be if it's approaching from the left, wouldn't it be an S like going to pi over 2?
So you're thinking left on a graph.
Yeah.
This is the unit circle. So when we're saying that we're approaching from the left, we're just talking about we're approaching from below 90,
And then
which is
if-
why I went to A. Does that make sense?
Yeah, but if it was positive, we'd be approaching from the right and be above 90.
I'm actually gonna show you. So this, if you remember, that was pi over 2, pi, 3 pi over 2, and 2 pi. So let's look at it on a graph, okay? What did that graph look like?
1, 0.
Yeah, go here, here, and then here. Yeah. Okay, so remember I told you there are a couple of different ways to think about this problem. So if you're looking at from the left on a graph, isn't that 0 to pi over 2?
Yeah.
Which is quadrant 1 here.
Yeah.
Okay, does that help? Does that make a
Yeah.
little bit more sense? So the two different ways, and then I'll get your question. The two different ways that we've looked at so far, cosine is what? Positive or negative? It's positive, right? We're doing limits. Trig limits. I know.
What is trig?
So, if cosine is positive here, cosine is also positive here, right? Because isn't it above the graph? Okay. So, if it's positive in both, what is this? Positive. Is 1 ever going to be negative?
No.
So, what's your answer here?
Infinity.
Well, remember I said this actually is 1 over 0, which is how we know that we are dealing with infinite limits.
So every time it's positive over positive, it's infinity.
It's positive infinity. Yes. Yes.
What's up? I think there's one
Um,
Oh, because this is
Doing now.
because it's X, it's pushing.
Chapter 2.
Oh, it's
Like quiz.
Way to quiz today.
no.
Do we want to make sure that the correct
It's
quiz was
going
given?
crazy.
Do you know when you gave like a homework quiz on
The negative means it's
Uh, 3 of them.
It's approaching from
Trig.
Do you want dates? I can give you dates.
This
2.1, 2.3,
Also known as killer software. 'Cause it makes
All
me look
information
killer.
has been supplied and given.
Studies.
Okay. Yep. You're welcome. All right, I'm leaving this up here for a sec. Sebastian, what was your question?
I don't know.
What?
Guys, anybody else? Questions?
No.
No? Does it make sense? Ish? Za? Ish? Yeah? You guys okay? All right, so I gave you two different ways to do this. Guys, either way is fine. And me giving you this, remember IU is anti-calculator. This is giving you a way to do this without a calculator. If you remember your cosine and your sine graph. All right, you guys ready to do the last one?
Yes.
Okay. So on the last one again, let's plug in 0. If we plugged in 0, what would we get? We'd get a -1 on top. That's going to be a 0, and that's going to be a 3. So when we have that 0 on bottom, remember I said that is when we have to do a double check. We're probably going to have an infinite limit when we have that 0 on bottom. Okay? So for this one, we're going to test both sides. Okay? So we're going to do this one slightly different in that we are testing both sides, but it's just another tool for you guys to be able to use to figure this out. We kind of did that in the first one, though, honestly. All right, so as we are approaching 0 from the left, we're going to figure out what that is. And as we're approaching 0 from the right, we're going to figure out what that is. In order for the limit to exist, what has to happen?
Go to the same.
They obviously have to equal the same amount, right? You're welcome. All right, so let's test it. I don't have to draw this graph to be able to test here. Okay, so let's just think about it. If I'm approaching 0 from the left, I'm in the negatives, correct?
Yes.
Negative whatever, okay? No whatever, negative something. All right, so look on top. If I plug in a negative anything into there, what's my top going to be, positive or negative?
Negative.
It's going to be a negative. Okay? If I plug in a negative anything here, oh, no, thank you. If I plug in negative anything into an x squared, what is that going to do?
Positive.
It's going to be a positive. I'm approaching 0, so what about here?
It'll be positive in there.
Most likely it would be positive, right? Most likely. Okay? So
Negative infinity.
this one would be negative infinity. Are you guys okay there? Okay. Now let's look at, we're approaching 0 from the right. Okay? So as we're getting really, really close to 0 from the right, we're obviously in the positives this time. Okay? So if I put a positive 0.01 right there, what is my top value?
Negative.
It's going to be a negative. Because remember, we want to get really, really close to it. So, picking 5, it just doesn't make sense. Okay? Because we want to get really, really close to that value of 0. All right, what about here? If I plug in a positive 0.01, it's going to be a positive. Here, if I plug in a positive 0.01, also positive.
So negative infinity.
So negative infinity again.
So that's our limit.
Do we have a limit?
Yes.
Yes, we do, because they are the same, and it is at negative infinity.
Hoorah. Hoorah.
Okay?
We're done.
What would happen if your answer was D and E? If the asymptotes were going in opposite directions, what are you going to see there?
It would
One positive infinity, one
One's
negative.
going to be positive and one's going to be negative.
Okay.
Does that make sense, guys? Yeah, sure?
So if they're
Now,
not the
these
same,
both
then it's
people are
D&E.
starting to show.
If they're not the same, then it's D and E. Yep, and that pretty much just means, yeah, you're going in opposite directions. Positive and negative infinity. Oh my gosh, I am starving. My tummy is hurting.
Get ready.
Same.
Negative